Okay, here we are. We're doing tables and graphs, um, and and we're doing what's here on this question. I'm doing question 4 here as a demo, and then we're going to add some other stuff to it, some of the work we've done last term. So we've got a pattern here, and this you can see it's got these little tiles, and I've got a blue shaded one in the middle, and around it there's these 4 white tiles. So here I've got 1 shaded and 4 white. When I've got 2 shaded, I've got 2, I've got 6. And then when I've got 3 shaded, you can see that I've got 3, 6, 7, 8. So look, we've really got whatever these are, we've always got 2 lots of whatever that is, plus the 2 on the end. It's interesting. Anyway, let's have a look at what we're supposed to do in this exercise. And we've got to draw up the graph. And so I've already done this, something I prepared earlier. And let's have a look at some of the things I put on there. I put a little arrow on the end. Notice that little arrow there. And I put an X down there. And I also said that these were the shaded, like here. So the X is the shaded tile. And on the up one, I've got a Y, I've got a little arrow, and I've put on there, I should put on there, white tile. Z. Okay, brilliant. And you can see this is important. Look at the grid. I've got 1, 2, 3, 4, 5, 6, 8, 9, 10, but look where the marks are, right on there. So that distance is 1. I'm going from 0 to 1 to 2 to 3. And these distances need to stay the same. That's why the grid's really helpful. I don't write the numbers in the middle, those little thing. That distance is 1. That distance is from 0 is 2. So it's a distance from 0. And then same going up. I started to write the numbers up, but because I was going up to 20, I decided to change it to go up by, I'm still going up by ones. I'm still going up by ones, but I only labeled every second one. Okay, and the important thing is that whenever you're drawing 1, this is like a number line, but going in another direction up here, you got to keep those distances the same. Okay, really important. Now let's plot these things. And so for 1 shady tile, shady tie, I've got 4 white. So for 1, I've got 4. And then when I saw for 2 shady tiles, I had 6, didn't I? And then for 3, I had 8. Now, what do we notice here is we notice, I'm just going to put, look, for every time I go across 1, I'm going up 2. Across 1, I'm going up 2. So I should be able to use that. I might go across 1, up 2, and I'm going to get a point here. And I can keep on doing that. Across 1, up 2, across 1, up 2. I can use a pattern. Our brains are set to notice patterns, and we can follow them. And algebra is about generalizing patterns. That's why mathematicians are right into it. Okay, so there's our little drawing, and I'm not going to draw in between those. Usually we might be able to connect them up, but I'm not going to do that because in this situation, I can't really have half a tile. I can't have, so 1.5 tiles or anything like that. So, because these are whole things. But sometimes when we're talking about numbers, we do join them in. And now let's answer the questions. So the questions are going to ask this. Let's have a look. Use your graph to predict how many white tiles are needed for 5 shaded tiles. So here's the shaded 5, ja, and I get that is going to be, so for when x equals 5, y is going to be equal to 12. And then for the other one, you use green. How many shaded tiles are needed for 18 whites? So in this case, we've got, okay, well, I'll do the, what am I doing? Green. 18 tiles of white. So I've got, these are my white ones here, right? So I'm going to go across the 18 and then down. And I can see that it's 8. So when x, or where y equals 18, y is going to be, x, is going to be 8. That's what we're doing at the moment. We're learning how to read these graphs. Now, the next bit here says to test your prediction by doing some stuff, right? But what we want to do, because we've got the skills from before, we want to use our algebra to check it out. And so when I'm looking at the rule for here, there's two ways I can do it. One is from the stuff that we've been doing before. We can see that the times tables here, because it's going up in twos, we know that this rule is going to be y equals 2 times whatever x is. And then we do something else. So let's test it. When it's 1, I go 2 times 1, which is 2. And how do I get to 4? I have to plus 2, don't I? So it should be, my rule should be like that. So let's test it with 3. 2 times 3 plus 2, 2 3s are 6 plus 2 equals 8. Yes, that works. So there's my rule. Let's test it. Let's check it out with this, what we found here. We've got y equals 2x plus 2. So when x is equal to 5, I go 2 times 5 plus 2. I might put my equals underneath each other like this. 2 times 5 is 10 plus 2 is 12. Yay. What about this one when I've got y equals 2x plus 2 is my rule. And I've put y equals 18. So I'm going to go 18 equals 2 times something plus 2. And this is stuff that we've done before. So I've times by 2 and then I plus 2. And that gets me what my answer is. But I know that when I do that I get 18. So to work out how to go backwards, opposite of plusing 2, minus 2, opposite of timesing 2, which is divided by 2. So 18 minus 2 is 16, divided by 2 is 8. And that's what I got here. So we're going to do more of this equation solving stuff soon as well. And there's my graph stuff.